Now that we know how to describe where the electron is using quantum numbers, we will now fill an atom with electrons. Okay, so if this is the nucleus, here are the energy levels. If you have one electron, obviously, because the electron's negative, it wants to be as close as possible to the nucleus. So it's going to go into energy level number 1. So in energy level number 1, there is only one sublevel, and that sublevel is the S sublevel. Okay, because there's not much room in there, you can only fit one S sublevel. In energy level number 2, you can fit 2 sublevels. You can have an S sublevel and a P sublevel. Okay, so as you go further and further out away from the nucleus, you can have more and more sublevels because there are more rooms. There's more room in space. So on the 3rd energy level, you guessed it, you get 3 sublevels. And so on. So you get an S sublevel, a P sublevel, and a D sublevel. Okay, so to fill it up, first you have to know that the S sublevel only has one orbital, and the S sublevel only has one orbital. The P sublevel has how many? You're right, it has three orbitals. The S sublevel has one orbital, the P sublevel has 3, and the D sublevel has 5. Okay, so now I'm going to fill it up with electrons. If I have one electron, I put it into that box, that orbital. Okay, if I have 2 electrons, like in helium, I can fit 2 in here. Okay, 2 in each box. Because they have different spins, they can stay together in an area in space, even though they're both negative. Okay, so if that's filled up, I have filled it up with 2 electrons, right? I can fill up the next one. So you go lowest energy level first and then the next one. So you go fill it up 1. If you have 3 electrons, if you have 4 electrons, you put it there. So now you have put 2 electrons in there. If you have more electrons, you fill this up with 1 electron. Okay. Now, first of all, there is something called Aufbau principle. Aufbau principle states that if you have to fill up electrons, you have to go to the lowest energy level first because it's closest to the nucleus, and then you go away from the nucleus. So Aufbau principle states that you fill up the lowest energy level first, closest to the nucleus. Because the nucleus is positive, and because of electrostatic attraction, it will go closer to it. Close to the nucleus is the most stable for the electron. Most stable. That says most. Okay, and the way I remember it is when you bow, you look down. So fill up lowest first and then go up. Okay. Now, if you have 5 electrons, it would look like this. If you have 6 electrons, you would fill up 1 there, the 5th electron there, and the 6th electron will go here on the next orbital. Okay, remember, each square is called an orbital. And all 3 of these is called a sublevel. Okay, you put the electron on the next orbital because they're farther away from each other and it's more stable as well. If you have another one, you put it in the other one. Okay, also, they're all going arrow going up, meaning the same spin. They found that it's more stable that way when they're all going at the same spin. This right here is called Hund's rule. Hund's rule states that you want to put the electrons in a separate orbital. That means the boxes, right? In each box first, and they must have the same spin. Of course, all pointing up or all going down, doesn't matter, before you double them up. Okay, so if you had more electrons, then let's see, 2, 4, 6, 2, 4, 5, 6, 7, the 8th electron would now go here, the 9th would go here, and the 10th would go here. So that gives you 6 electrons. Again, the exponent is the number of electrons in that energy level. Okay, you can actually fit up to 6. That number can be lower. If you only have 5 electrons, then you just put 5 there. Okay, and just keep going and going and going. So the way this looks is this. Oh, first of all, this right here is on the first energy level, as you can see. Energy level 1. So you put a 1 right here, so you can differentiate it from the other S. This one is 2, so you put a 2. This one's 2, so you put a 2. So you put the energy level in the front, so you don't confuse the 2S sublevels. The one in red is called the energy level. The one in pink is the number of electrons. And the one in blue is the sublevel it's in, or subshell. Okay? So if you have, for example, this would be, so let's show you how it looks like first. So in the three-dimensional system, it would look like this. So first, you have 2 electrons. Oh, let's say what element this is first. 2, this is, if you look at the periodic table, 6, 7, 8, 9, 10 electrons. 10 electrons would be neon. So this is how the electrons in neon are arranged. So it has 10 protons, so it has 10 electrons. So we're doing neon, okay? So neon, the way the electrons are arranged in neon is you put the first 2 electrons here, so you just write that down, 1s2. The next set of electrons is 2s2, and then 2p6. Okay, so this is how electrons are in neon are arranged. This is called electron configuration. Electron Okay, so configuration is another way of saying, like when you configure something, you arrange something. So this is the electron configuration of neon. It is 1s2, 2s2, 2p6. Okay, so the one element before that would be, let's see, it would be fluorine. It has 1 less electron, so the electron configuration for fluorine would be 1s2, 2s2, 2p5, because there are only 5 more electrons in there. Okay, so electron configurations tells us how electrons are arranged or configured or arranged. And again, the 1 is the energy level. The S is the sublevel, and the 2, the exponent, are the number of electrons. So you can see if you add the exponent, 2, 4, 6, neon has 10 electrons, 10 protons, and 10 electrons if it were neutral. Okay? So in a three-dimensional system, it would look like this. Let's fill the atom with electrons. So you have 2 electrons in the 1s energy level. This is the 1s in there. So 1 arrow going up, 1 arrow going down. Once that's filled up, you fill up the second energy level. So this is a 2s sublevel. 1 up and 1 down. When that's filled up, you fill up the p sublevels. So, the p orbitals or the p sublevels. So there are 3 of them. So here's 1. You fill up 2 in there, you fill up 2 in there, and you fill up 2 in there. So 2, 4, 6. And then you keep going. And as you can see, it can get messier and messier as you go up. Okay? After you do the 2p, then you fill up the 3s, which is this big one right here. You fill in 2 more electrons. That would be 2 more electrons after neon.